Hi, Assalamualaikum. Okay, today we are going to continue our heuristic search techniques, and now we are going to look at how we are going to do heuristic search in games. Okay, uh, the first technique that we are going to look at is minimax. You can see here in minimax algorithm, we usually perform the search techniques onto a state space search where you already know the value of the leaf nodes. So in minimax algorithm, usually you are trying to uh, solve a game problem, and at the same time you are trying to have a winning situation for A. You want to win. You are looking for a best way that A will win. Okay, so minimax is an easy technique. Usually in minimax we will identify what is the goal of the problem first. For example, in this module, you are given for the first example here, consider the following game tree, find the best move for the max player using the minimax procedure. Okay, so I've copied this tree into this note here for you to view it easily. Let's see how to solve this problem. Okay, usually when we identify the question, we want to know what is the goal for A. Are you going to maximize A or minimize A? If you are trying to maximize this level, you will always want to minimize your opponent marks, your opponent score. So you want your score for the opponent be minimized. Alright, so then this is your move again, and this will be min. Okay, in this tree, usually you already given the value for each move. What is the score if you take this move? What is the score if you take this move? So for minimax, it's easy because you just have to identify. In this level, you have to find the maximum value between 2 and 3. So you just take 3 here. Okay, maximize the value of 5 and 9, you will get 9 here. If you only have one branch, you just straight away take the value. 7 and 4, the maximum value is 7. 2 and 1, the maximum value is 2. And 5 and 6, the maximum value is 6. So go to the next level. This level, you're trying to minimize your opponent's score. So if you have 2 root here, you're trying to minimize the root in front of you. So 3 and 9, the minimum value is 3. 0 and 7, the minimum value is 0. 2 and 6, the minimum value is 2. And again, if you're trying to maximize A's move, so A will take the maximum value of 3, 0 and 2. So A will be 3. Okay, so this is how you solve the problem for minimax technique. Okay, now we are going to continue to the next one, the next technique in heuristic search in games, which is alpha beta pruning. We are actually extending the technique of minimax because the minimax is one technique that it search the entire tree in order to identify which is the best solution. However, in alpha beta pruning, we kind of have a prediction before we are going to look at the whole entire search tree. So in alpha beta pruning, we have another technique. When we are going to identify the result for E, if you remember earlier, when we tried to solve this problem, the same tree using minimax, we always identify what is the goal for A. If we are trying to maximize A, we should identify what is the goal here. So I'll write here we want to maximize this level. If you are trying to maximize this level, you always try to minimize your opponent, and then you try to maximize your score again, and the last one should be minimized. This is the case where you have 4, 3. Okay, now in alpha beta pruning, if we try to minimax something, if we try to find the maximum value for something, it is always important to identify more value. We want to know more. What is the more value for each branch? So if it's minimum, so you try to find the less value. If it's maximum, it is more value. Okay, so in alpha beta pruning, you always start to all the way down here on your left. Sometimes it will ask you to start from the right. If it does ask you to start from the right, then you start from the right. But usually you will go to the most least value, either right to left or left to right. So we will start this technique with left to right. Okay, so we should identify. First, we identify, is it maximizing or minimizing? If maximize, so you put more than here. Minimizing, so less than. Maximizing, more than. So the first thing you have to do is identify what is the intermediate value here. Intermediate value here depends on this value. So the first one, you are trying to find something maximum from these branches. So you look at the first branch, it's 2. So you want to find something more than 2. So when you get this, you have to check with its parent value. Do you have any value here? No, not yet. So you go to the next one. Okay, go to the next value, 3. Is 3 more than 2? Yes, 3 is more than 2. So you have to cut off this one, move it to more than 3. If this is the last value for this branch, so this last value on this will be brought here. Okay, so now you have here the first value you should assign here is less than 3. So whatever value here you are trying to maximizing, it should not be more than it should not be less than 3, because in this level you are trying to minimize. So you don't want to find something that is bigger, because you want to minimize this value. So it should not be more than 3, it must be less than 3. So if something here is more than 3, you should just stop. Okay, so this level it will be more than. So you see here, it will be more than 5. So if you look here, this is more than 5. Here you are trying to find something less than 3. It is not possible. It is just not logical. If you see this number, the number line number, if this is 3 and this is 5, if you're looking at something that less than 3 and more than 5, it is not logical. This is actually not possible. So one way, what we should do now is to just prune out this branch. Okay, because whatever value that you get from this branch, you will not bring it here, because here in this level you're trying to maximizing it. So when you try to maximize this, which is you're trying to find more than 5 in this branch, but whatever more than 5 is not logical, because in the first place you're trying to minimize it less than 3. So you just prune this one, so you just cut it off. Okay, I'll do it like that. Okay, now we go back here. So as we say just now, more than 5 and less than 3 is not logical, so we didn't change this value, so it still be less than 3 here. So 3 will go up here. The same thing happens here. You will have to find something more than 3. Whatever in these branches, if it's less than 3, you should not want it, because you are trying to maximizing A. Okay, so look at here, you will be less than. You don't have any value here, so go down. You will have here more than 0. And then, as you know, you don't have any branches here, so you just bring 0 here. Okay, so 0 will be here. Look at this value, less than 0 and more than 3. Is it possible? This is another unlogical value. okay? Because if you look at the line, if 0 is here, 3 is here, when something is less than 0 and more than 3, it is not possible. No numbers is actually filling this criteria. So what happens now is you just, if this and this is not logical, so you just prune whatever you have right to it. Okay, so 0 will be here, 0 is not more than 3, so your value is still more than 3. You go to this last branch, you're trying to find minimum here, maximum here. Okay, in this branch you don't have any value, you go down, more than 2, compare with the upper value, but there is no value here, you go to your right. Is 1 more than 2? No, so still more than 2 here. You go to the right, but there's no more branches, so 2 will be here. Okay, so less than 2, more than 3. Again, that is not logical, because if you look at the number, this is number 2, this is number 3, less than 2, more than 3 is not logical. Okay, so when it's not logical, so what should we do is, we just have to prune this value here. So less than 2, more than 3 is not true, so you will still have, this is 2 going out here, 2 is not more than 3, so you still have more than 3 here. So the last value here will go up. Okay, so to make sure you've done it correctly, you can compare it with the result that you get from a minimax. The final result up here should be the same, okay, because you're doing maximizing A. But if you realize in this case you are not looking at all branches, some branches you just prune it out, so you don't even look at it, because this is one way to save your time. So it is simpler because you don't have to look at all the branches, but it involves a little bit more steps.